Hey guys, today I'm going to be looking at simplifying rational expressions and finding excluded values. If you're following along in the book, it's from Algebra 1, Unit 6, Lesson 5. Alright, so rational expression is just a fancy word for a fraction. We just happen to have polynomials on top and bottom. So we want to simplify those and also check for excluded values. Because when you have a fraction, remember, you cannot have, again, if we have fraction, b cannot equal 0. You can't divide by 0 because that's undefined. So when you're asked to find excluded values, they're simply saying what would make the denominator 0, because we don't want that. So to find your excluded values, you set your denominator equal to 0 and solve. So again, when you're asked to find those excluded values for these rational expressions, you're setting the denominator equal to 0 and solving to see what's going to make it 0. What do we not want to include? Because we don't want the denominator to equal 0. And when you're asked to reduce, you need to factor, and you can then cancel common factors. You cannot just cancel terms. You only can cancel common factors. The whole factor has to cancel out on top and bottom. So let's look at an example. Let's say that we have 3x squared plus 7x plus 4 over 9x squared minus 16. Okay. So first, before I find excluded values, I'm going to just go ahead and factor as much as I can first. So I'm going to factor the top. There is no GCF there, but this is a trinomial, so I can do asterisk method. A times C would be 3 times 4, which is 12. B is 7. And remember, I put AX here, so it's just that first part without the squares, that 3x squared, but don't include the squared portion. And I need to find two numbers that multiply to 12 that also add up to 7. So that I've got 1 times 12, that's not going to work. 2 times 6, that's not going to work. 3 times 4, that would work because 3 times 4 is 12 and 3 plus 4 is 7. But now I need to reduce these. Okay. Well, the 3x over 3, I can take out a 3. So this just becomes 1x over 1. So my factors are 1x plus 1 or just x plus 1. And then the 3x over 4 doesn't reduce, so that's 3x plus 4. So this 3x squared plus 7x plus 4 factors into x plus 1 times 3x plus 4. Now, this 9x squared minus 16, there's no GCF, and that is a binomial. It's one of those special products. That's a difference of two squares. Okay. So remember, difference of two squares, you're going to get two new binomials multiplied together. One's plus, one's minus. We take the square root of 9x squared, which would be 3x. That goes in the front. And the square root of 16 is 4, so that goes here. So 9x squared minus 16 factors into 3x plus 4 times 3x minus 4. Now, before I cancel anything, I do need to find my excluded values. I need to set the factors in my denominator equal to 0. So I need to set 3x plus 4 equal to 0 and the 3x minus 4 equal to 0. And then I solve. So I'd subtract 4 and divide by 3. So one of my excluded values, I'm going to write it over here, is negative 4/3. And then I've got to go over here, I've got to add 4 and divide by 3. So I'd get positive 4/3 for that one. So my excluded values are negative 4/3 and positive 4/3. If we plug those two in for x, we get 0 in the denominator, which we don't want. Okay. Now I'm going to come back up to here where it was factored. And if I see any common factors, the entire factor has to be the same, then I can cancel those out. One has to be on top, one has to be on bottom. I see a 3x plus 4 on top and a 3x plus 4 on bottom. Those are entire factors, so I can cancel those out. Okay. But I still have x plus 1 on top and 3x minus 4 on bottom, so I need to rewrite that. I've got x plus 1 on top over 3x minus 4 on the bottom. This would be our answer after we reduced it. these are our excluded values here, and this is our answer right here after we reduce.